Hello. Good morning, Kriti.
Good morning, sir.
Yeah. Today we are going to revise the topic on differentiation. We already completed this topic in our curriculum, is it?
Yes, sir.
Yeah. Let me have a brief introduction and revision quickly on differentiation. Can you please tell me differentiation where we going to use?
Uh,
Yes, I will going to help you fastly.
Maths.
Yes, in max it is good, right answer. But differentiation is a sub branch. We're going to get it in the calculus. It will be going to use for finding the tangent to the particular point of the circle. It is used to find the slope of the given line. Here slope means amount of bending. Amount of bending or amount of inclination, we're going to call it as slope. If a particular line is going to be like this, how much is bended with respect to x-axis or with respect to y-axis, like that we can find by using the differentiation principle. I think that we discussed it, right?
Yes, sir.
Yeah. So differentiation can be defined by a formal formula, that is limit delta x tends to 0, or you can use any other parameter as well. Limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. You have to write the differentiated value as f dash of x. That dash indicate the given function
Differentiate.
is differentiated one time. The other way representation of the differentiated values will be y1, and even you can put that one as y dash. These are the other way, and mostly we are going to use dy by dx in all our applications. Means y, if it is a dependent function, x is the independent function, dy by dx indicates you that dependent function is differentiated one time with respect to x, dy by dx. I think all we discussed in brief in the regular session. Is this clear to you?
Yes, sir. It's clear.
So now let me go into see what happened with the other, where all the functions are going to use differentiation and how it will be used and rules of differentiation. So trigonometric ratios can be differentiated, that you know that in our regular class. For brief discussion I will put a heading here. Let me going to write the trigonometric ratio. You need to tell me that particular differentiated value for it. Can you please tell me what is the differentiated value for sine theta?
Cos,
Very good. Please be loud and clear. Cos theta.
cos
What is the differentiated value of cos theta?
minus sin theta.
Very good. Okay, what is the differentiated value of tan theta? Secant square theta. Okay,
Secant.
what is the differentiated value? Next three trigonometric ratios what you're going to have, Those are
Mm.
all going to call reciprocals of the basic trigonometric ratios. We have totally 6 trigonometric ratios that you know well. In that,
Yes.
3 are fundamentals, other 3 are reciprocals. So for sine, reciprocal is cosecant, and then for cos,
Cos.
reciprocal is secant, tan,
Sec.
reciprocal is cot. For that also we already derived the list. You have already supplied with the differentiated trigonometric ratios list. Just for revision I put it this 3. That 3 you can going to do it more exploration. Okay, if you get doubt I will be helpful for that. And exponential function. How exponential functions will look like? E to the power x.
To the
If you're going to differentiate this, we need to put it y is equal to e to the power of x. Y is the dependent function.
differentiated value.
Dependent function. E to the power of x is the independent. Here e is the exponential, x is the independent variable, y is the dependent variable.
Dependent.
If you use that one in the graph, y is equal to e to the power x if it is the function, then this will be the x-axis. X-axis is the independent. Based on the value of x, y values are dependent. That is why x is independent, y is dependent. As you are eligible to choose the value of x according to your wish, but value of y is confined from the value of x. So y is called dependent, x is independent. If it is exponential function, it will be growing. Okay, this is called positive exponential. If you're going to write minus y is equal to e to the power minus x, y is equal to e to the power minus x, at that time that exponentially decay. The first one is exponentially increasing, this is exponentially decreasing. Another word you can put it as exponential decay. Fine.
Yes, sir.
Yes. If you differentiate, what happen? Differentiation is nothing but, as I told before, it is for finding the slope, amount of bending, or finding the point of contact to the of tangent to the given circle. So here we need to find the slope. At any point you consider, the slope will be remain same. So what? Dy by dx is also e to the power of x only. Exponential function, if you differentiate, you're going to get exponential only. Understood?
Yes, sir.
We already derived this one also by using the fundamental formula. And next we're going to go for logarithmic function. That logarithmic function is going to be useful when you not able to apply the power rule. That will be helpful to differentiate if they having a very large number, and by using the logarithmic principle we need to do that. We have 3 basic logarithmic function that you know, that logarithmic identity we going to call log of AB. Can be written it as, can you tell if you
Log
remember?
A plus log
Very
B.
good. Log A plus log B. What about another? Log A to the power m?
A log A.
Yeah, I will tell you. Don't worry. I will make you revision. Log A plus log B. It is log of A to the power m is my next result. Next identity you need to remember for doing the problems for differentiation. Log A to the power m. Log A to the power m can be put it as m log A. Do you remember?
Mm. Yes, sir.
That power is come to the multiplication, become multiple. Yeah. If it is log A by B, that become log A minus log B. These are
Log
the
B.
3 identity. For that we going to use the logarithmic differentiation. We know that when we put logarithmic differentiation to any value, it become 1 by that. Log x differentiation is 1 by x. Is it so?
Yes, sir.
Yes. So we need to put d